Similar to part 2 of this question, this is once again another hypothesis test question where the conclusion is given and we are supposed to work backwards to find one of the unknowns, and this time the unknown is the sample variance. The conclusion is given to us as the null hypothesis is going to be rejected. Well, let's start by writing down the three parameters: n, the sample size, this is 10, and the sample mean, which is t bar, and this time round it is given to us by the question as 4.0. Right, then the population variance, which we do not have, that is why we are calculating the unbiased estimate to the population variance. I'm going to use this formula, n over n minus 1 multiplied by the sample variance, which is 10 over 10 minus 1 multiplied by k squared. So it is 10 over 9 of k squared. With n that is small and the population variance that is unknown, this is going to be a t-test once again. So I'm going to write down my test statistics with a t distribution. My test statistics is going to be a t distribution. It is going to be equal to x bar minus away 4.3 divided by square root of 10 over 9k squared divided by the sample size 10. This is going to be equal to x bar minus 4.3. Let me simplify this a bit. So it is square root of 1 over 9k squared, which will follow a t distribution of n minus 1, 10 minus 1, so this is 9. It is given to me by the question that I'm supposed to reject the null hypothesis, which means that the p-value must be less than the level of significance of 10%. So this must be less than 0.1. It is important for us to know how to calculate the p-value. In this case, it is a left tail test. So if I were to look at the distribution curve, okay, here it is 4.3. It is the population mean, and the sample mean is 4.0. It is on the left hand side, and the area that is on the left hand side of 4.0, this is going to represent for us a left tail test, the p-value for a left tail test. Okay, so this is probability that x bar must be less than 4.0. This is less than 0.1. Standardizing to a t distribution, that means probability that t is less than 4.0 minus 4.3 divided by 1 over 9k squared. This is going to be less than 0.1. For this that I have here, I just need to try to find a range of values for this, and that can be easily done by pressing my calculator for an inverse t, with the area as this and the degree of freedom as 9. Pressing my calculator for inverse t, this is minus 0.3 over square root of 1 over 9k squared. This is going to be less than minus 1.3830. Right, cross multiplying, minus 0.3 is going to be less than minus 1.3830 square root of 1 over 9k squared. Now I shift this over because it's negative. The inequality sign here is going to change. So square root of 1 over 9k squared. This is going to be less than 0.21692. I'm going to square both sides. 1 over 9k squared is going to be less than 0.047054. Which means that k squared is going to be less than 0.423.